Exercise A01 is going to be pretty much focused on testing the size of operator. So I'm putting up here the description of the exercise, as you can find it in the Blackboard site. We want to have a program. Let's look at the output directly. We want to have a program which is going to display the name of a couple of data types. Okay, and it's going to display the size expressed in bytes of each of those data types. So to do so, we're going to use the sizeof operator. I'm going to run with you through a couple of these, and I will let you finish the complete list. Knowing that, understanding that, some of the data types that are listed above are not valid data types. So it's just to try to point out to you that not all combination of unsigned and the name of a data type, long and the name of a data type, etc. are valid. So it's just there to point your attention to that. And there's nothing better to remember which one are valid and which one are not valid than to get an error in a program that we do for practice. So that's why I'm asking you to go through this entire list and pick up which one are valid, which one are not valid. Okay, so let's go to the Conqueror window. We're going to create a new file. So I'm going to do create new, file, text file. I'm going to call it a01.c. And there we go. I should have my first C file here. I click on it once. This is going to open the kwrite editor, which is right here. Oops. Let's put it back in the foreground. And I'm going to have an empty file. This is going to take a couple of seconds here. And I'm going to have an empty file which I can start populating with the boilerplate code. I'm going to do some printf on the screen, so might as well get ready and include stdio.h. And I'm going to start by doing a simple printf data type. I'm going to use a \t special character in printf, which means tabulation, and size in bytes. Okay, as usual, I'm going to recommend that you do that all throughout the semester. I'm saving. I have a very minimal program. Maybe I did a little syntax error in the pound include, maybe something is wrong, I don't know. I'm going to consider this as a checkpoint. I am done with writing the first line of my program. I am going to compile this program. And you can see here that I have already something to pay attention to. So it's worth compiling frequently. Every time you make a little change, a little modification, you are going to stop, compile, verify that everything is working. If the program runs it, run it to test it, and then go on to the next change. What you see here is actually a warning, but I'm going to take care of every warning that we have in those little exercise. This is a warning that normally the GCC compiler would not mention, but because of what we're using, the script we're using, all the warnings are turned on with this option, -w all, which means warn me about everything you can. This allows you to, once your program compile, to be a little closer to have a very functional program instead of just compiling stuff that might contain still errors that are going to manifest themselves later. So I'm going back to my code. What the compiler is complaining about, let me minimize the code a little here. Okay, what the compiler is complaining about is that control reaches the end of a non-void function. Well, this is our main function. It is indeed non-void. It's supposed to return an integer. We're going to discuss about that in more detail when we cover the function in C very soon. So here, to be able to pass all the warnings in my compiler, to be able to pass all the verification my compiler is doing, I'm going to have to say, at the end of my main, I return 0. If I reach somehow the end of this code and I never return anything of type int, then there is a problem. So there we go. I'm going to try to make the compiler happy. I go back to my Conqueror window. GCC A01. That's it. Nothing. So now I can test it real quick. Data type, what appears to be a tabulation, and then size in byte. And then immediately my prompt is there right after. Okay, this is not acceptable. I want to make it look a little better. So once I'm done displaying size in byte. I want to go to the next line. I'm saving this file. I'm going back to Conqueror. I'm compiling. No syntax error, that's good. A.out data type size in byte. So you see how, and you probably are already, how to say, you are probably already used to that, but you see how the programming process is really iterative. You can make small modification, progress, make sure your program compiles, make sure it works, then move on to the next small modification, etc. This is actually a good recipe to avoid introducing a lot of bugs in code, okay? The opposite of this would be to have a programmer that goes nuts on the keyboard, types 3 pages of code because he's sure of his talent, and then only after typing 3 pages of code, try to compile it to make sure that he didn't, type something wrong. Well, that would be exactly the opposite of what I want you to learn to do when you are developing code. So, alright, we have just the first line done here. Okay, let's go back to the text of this exercise. We display a header, and then we display some information about different data types. So let's go and move on to that part, which is really the core of what we want to do with this program. So I'm going to display int \t tabulation, and then I'm going to display, after that, I'm going to display %d, a decimal number. Go to the next line. The value for %d will be given by the expression sizeof, and I'm going to put here, of course, the same type which I just mentioned. I was going to display the size of. So let me compress the space here. We'll see if we need to put some or not, and I will explain you why. Right now I want to display int, a tabulation, and then an integer, which is a result of calling sizeof. I'm going back to my Conqueror window. My file is saved. I use the upper row to call previous command, gcc a01, compiles without problem, a.out. Alright, it's working, it's doing its job. It's telling me an int is 4 byte. However, I don't like the presentation here. It seems the colons are misaligned. Why is that so? Well, tabulation work every 8 character or so you have a tabulation. So here, when I say go to the next tabulation, I find myself here. So I'm going to rectify that by moving one more tabulation to the right, and hopefully that will make up for the fact that int is a very short word compared to the phrase data type. So I'm going back again to kwrite, and I'm going to say, well, let's use 2 of those tabulation to see what happened. I'm saving, calling gcc again, calling /a.out again, and this time my program is correctly aligned. So now that this part is done, we can go back once again to the code, and I'm just going to do another one just for the sake of it. So I'm going to display the size of a double, 2 tabulation, %d, and I could do here size of double, no problem with that. This is correct syntax. But I could do also double x, declare a variable of type double, which I initialize to 0, why not? And then I could display the size of a double by displaying the size of the variable x. So I'm not going to go through the entire list and do every single printf, okay? By now you should see pretty much how to do the rest on your own. However, I'm going to insist on the fact that sizeof, the sizeof operator, can be used with the name of a data type, a primitive data type in C, or with the name of a variable. Okay, and we are going to test that immediately. So I'm compiling a.out, and I should rectify a little my display. You see that it displays the correct information, but it's really not formatted in a readable way. That's because I forgot to do \n here and here. So I'm saving again, and then I'm going to once again compile, and I'm going to execute. This is a little better. Okay, size of a double is 8 bytes, size of an int is 4 bytes. To conclude with this exercise, C is not really a portable language. Okay, so whenever you move from one platform to the other, for example, from Linux running on x86 hardware to, I don't know, Solaris running on Spark architecture, you have to check your documentation to know exactly what are the size of the primitive data types, okay? Most of the time, if you develop especially application, you won't have to worry about that. If you are a little bit more of a system-involved programmer, you are programming at a lower level, this kind of information can come really handy.